Okay, so last winter we had a very cold winter. I don't know if you remember that, but it was freezing. And there was a lot of talk about this thing called a polar vortex. And if you look at the reports for this coming winter, it looks like we're going to have a similar winter as last winter. So I want to explain what the polar vortex thing is all about, and sort of the forecast for future winters and why we think the future winters are going to change. So to understand the polar vortex, we have to understand that there is a temperature gradient on our planet, and it is colder in the polar regions, both the Arctic and Antarctica, than it is at the equator. Okay, and that is because the equator gets more direct sunlight year-round than the poles do. So this is showing you an image of energy across the planet. On the y-axis is watts per meter cubed. So this is the energy over an area. Okay, meter squared is an area. And then this on the bottom is showing you latitude. So this is the North Pole on this side and the South Pole on this side. And it's showing you in the red and the blue where we have excess energy on the planet and where we have a deficit of energy. So what you can see is there's a deficit of energy at the poles, and there's an excess amount of energy along the equatorial area. So what happens is we get a temperature gradient that goes cold to warm to cold on the planet, okay? And in meteorology, we know that wherever the temperature gradient is strongest, so wherever on the planet we have areas that go from very cold to very warm fast, that's where we have winds on the planet that are their fastest. Okay, so the stronger the temperature gradient, meaning the higher the difference is between the temperature at two locations that are near each other, the faster the wind is going to move. Okay, and we have fairly strong temperature gradients that fall in this region right here between about 50 and 30 degrees, north and south. And this is where we find the jet stream. Okay, and the jet stream is probably something you're familiar with. You hear it on the news all the time. The jet stream is formed because of the strong temperature gradient that is between the Arctic and the United States. Okay, so if you look on a weather map, so now the equator is here and the North Pole is here. Okay, so we're looking a little bit different. That strong temperature gradient between the very cold North Pole and the fairly warm southern part of the United States and Mexico, that strong temperature gradient creates strong winds that come across this region of the United States. That's called the polar jet stream. Okay, and the polar jet stream, when there is a strong temperature gradient, tends to wiggle a little bit. We call these wiggles Rossby waves. Okay, but it doesn't wiggle tremendously large. You get this nice little wiggle. Okay, and this carries warm air from the south up into the U.S., and then it can carry cold air from Canada down into the U.S., depending on where we are with respect to the ridge and to the trough. But what has happened during the last several winters, particularly last winter and is forecasted for this winter, okay, is that the temperature gradient between the North Pole and the United States is starting to dissipate because of global warming. The North Pole is starting to warm up faster than the U.S. is warming up. So the difference in temperature between the Arctic and the U.S. is not so great. And that means that the temperature gradient is weaker, and what happens with the jet stream is it gets bigger wiggles. Okay? So it goes from being something like this with a small wiggle to having these really big wiggles like this. Okay? These really big wiggles can do two things. If the United States is here and we're downwind of a wiggle that's coming up from the south, we're going to get nice warm air. Okay, next week it's forecasted to be back in the 50s, right? But if we're sitting on this side of the ridge and that wiggle gets really steep, we're going to get lots of cold air coming from the north, all right? So last year what happened was that we ended up having somewhat of a standing wave in these wiggles, right? And we got this cold air that came down. So we have this ridge coming into the United States, and all of this cold air was brought down into the U.S., and it was brought down again and again and again, and it sort of was just a stationary situation, right? And we got that's what the polar vortex is. We got all this cold polar air coming down into the United States. A lot of people said, well, that's a sign that global warming isn't happening. That's actually not true at all. In fact, it's a sign that the Arctic is warming, because this happens when the temperature gradient between these two locations is weaker. Okay, so if we look at an actual weather map, this is for today. Okay, this is November 19th at 12 Zulu. 12 Zulu is 12 o'clock in Greenwich, England, so that's about 7 a.m. this morning. All right, and what you notice in today's chart is that we have a huge wiggle in the upper atmosphere. So you can see these are called isoheights, these blue lines, and they indicate where the upper atmosphere is flowing. And you can see it goes all the way up into, this is up near Alaska, and then it comes swooping down into the United States. Now it's been, what was it yesterday, 18 degrees? Mm-hmm. Okay, it's been very, very cold. And the reason that has been so cold is because, I mean, if you look at Pennsylvania, which is right here, and you trace the air back, the air is coming from all the way up north of Alaska, okay? So we're getting this very cold air mass. And again, the reason that we're getting that is that this jet stream has a huge wiggle in it, a huge Rossby wave. And if that continues through the winter, then you can expect, especially if it becomes stagnant like it did last winter, you can expect that this winter is going to have very cold temperatures. Now we know going into next week that this ridge right here is moving east. Okay, so it's slowly, throughout the weekend, it's slowly going to move in this direction, which means we'll get more warm air coming in from this region by next week. Okay, so right now we're still at a position in the winter where this is not a standing wave. This is going to start to dissipate and it's going to start to move east. But as we move into the winter, we can potentially get into a situation like last year where this wave, this ridge, becomes more of a stationary figure or feature in the upper atmosphere. And if that's the case, we're going to continue to get this cold air coming from the north. All right, so that's the forecast. The forecast for this winter is that it will be a lot like last winter. And if you forecast looking at climate change, we can expect to have a lot more winters like this coming our way.